All right, guys. So, really quickly, I'm going to start going over the practice quiz so that we understand that how to apply some of these ideas of pressure and wind. I'll also go over the pair deck and kind of what I was looking for that. Thank you, everybody that already submitted their answers. Hopefully, you'll learn a lot. Um, so, just in general, when we're talking about the wind, wind is nothing more than the moving of air. Now, the different things that can cause wind include things like the pressure gradient force. That's usually our main driver of wind, but it's also not in the same direction as wind. So, in the end, we're really just referring to wind as moving air. All right. So, we talk about the pressure gradient force going from high pressure to low pressure. We also talk about the Coriolis force. Now, the Coriolis force is not universally applied because the Coriolis force acts to the right of our wind direction in the northern hemisphere, but it acts towards the left of our wind direction in the southern hemisphere. So it does not always act to the right of wind direction, although, with a little bit of more qualification, you could say it always acts to the right in the northern hemisphere. That part would be true. Um, when we talk about pressure and the pressure gradient force, there's all sorts of different ways that we can measure pressure. A lot of times we talk about millibars. I don't know why that was the least selected wrong answer. Yes, atmospheres, pascals are pretty close to millibars. It's all about the same um, unit, but yes, pressure can be measured in all sorts of different things. All right, so this is what we were saying before, and in terms of our cardinal directions, it does not have a universal, Coriolis force acts south or west. It just acts to the left. So you have to think about what that means. I'm sorry, I mean right, in the northern hemisphere. All right, so some of these other questions really involve thinking, well, if I'm headed this way, what direction is right? If I'm headed this way, what direction is right? And that's where things can get a little bit tricky. All right, so now a force, and then, I know we're not all coming from physics class, but a force causes a change in something's motion. If there's unbalanced forces, something will change in its motion. It will get faster or slower, or it will change its direction. So when we talk about a condition in which the speed and the direction are constant, it means that all of our forces are canceling each other out. And so that's a very important thing to consider. And the other thing is that just because forces are canceling out doesn't mean that something's not moving. All right. If somebody is parachuting down and they quit speeding up, right? They're going to fall at a constant speed. Well, their forces have canceled out, but that doesn't mean they're going to stop moving, right? An airplane can be going through the air and gravity's still acting on it, and air, resistance is pushing up on it. The lift of the wings is pushing up. Well, the airplane can still move at a constant speed. And that's actually a pretty good analogy for what happens with our pressure gradient and Coriolis force when we talk about this. So if I'm thinking about a wind speed, all right, so I'm just going to say, all right, if this is the direction of my wind, or let's just, yeah, if we look here, right, now we can think about this as a wind, looking at the map. The wind can be moving in one particular direction, but if it's at a constant speed, what we can also say is, well, these other forces have to be canceling out. Now, the let's just say this is the northern hemisphere. All right, northern hemisphere, well, my Coriolis force is acting towards the right of my wind. Well, that must also mean that there has to be another force canceling out the Coriolis force acting to the left of my wind. And normally when we're talking about these forces canceling out, we're talking about pressure gradient force and the Coriolis force. Okay, so now this is where you really have to do a lot of logic, and it seemed like, well, we did okay. All right, so we're going to assume that we're in the northern hemisphere, so that means that our Coriolis force is acting towards the right. And we also know that our wind is directed towards the west. So I got to draw the wind, right? I'll be my wind. Then I can show that to the right of this is going to be my Coriolis force. So in this case, that would be in the north. All right, if the Coriolis force is to the south, all right, so my Coriolis force is to the south, what direction is the wind blowing? Well, again, this south-facing wind has to be to the right of my wind direction. So the only way that's going to work is if my wind is blowing this way, right? Okay, so my wind is blowing east, and my Coriolis force is to the right of that, and it is south. Okay? All right, so when we talk about geostrophic balance, specifically, that's when we're not considering some of these other forces and we're just looking at pressure gradient force and Coriolis force. The other force that eventually we do want to consider, especially at the surface, is the frictional force. Because the frictional force slows our winds down a little bit, and it means that our Coriolis force also gets a little bit weaker, which means that at the surface, we don't tend to have these parallel, winds that are parallel to our pressure lines. They'll actually cross over because the friction slows them down, and our winds will cross over towards low pressure or away from high pressure. Okay. So again, all these questions, this one could have been debatable, I guess, because we do focus mostly on the northern hemisphere. So we kind of answered this one already. The Coriolis force is to the south. All right. That means that we know that the wind must be towards the east. It also means that the pressure gradient force is going to be acting opposite that because they're already in balance. So the pressure gradient force would have to be facing north. This is a very hard thing to try and do if you're not drawing something out. It's very hard to just visualize all this going on, yet at the same time, if you do start drawing these things out, it gets a lot easier. So, for example, we could say, all right, well, let's just see. All right, so I've got my Coriolis force. All right. And what I want to do is try and figure out what direction my wind is. Well, one, you know that it kind of acts at a right angle, right? So you at least know that the wind is going to be somewhere along this line. But the question is it headed this way to the right, towards the east, or is it headed this way towards the west? Well, now I can at least kind of visualize it a little bit better to say like, oh, well, if the wind direction is to the east, then when I go right, rotate to the right of that, then I'm going to be going south. Yes, my wind direction is here. And I also know that I've gotten that balance, that geostrophic balance, and that means that the pressure gradient and the Coriolis force are going to be in the opposite direction. All right, I think, did I hear somebody come in? No, maybe. So if you have any questions, go ahead and comment, but otherwise I'm just going to keep on going through these. So we can go to the next one. All right, so now we know what direction the pressure gradient force is. All right, so again, this is actually the same thing, right? The pressure gradient now I know is north. That also means, right, if it's geostrophic balance, that my wind is south, or sorry, not my wind, my Coriolis force. And I've got to have a wind that is blowing in these directions. So, you know, since there's a lot, for a lot of these three different things we're talking about, pressure gradient, Coriolis, and wind, you can be looking at the same situation as answer for different parts of these results, okay? So that is a very important skill. For your quiz questions, we will be assuming that we're in the northern hemisphere because those are the maps that we look at. Those are the other things. So other than just understanding that in the northern hemisphere, it's different than in the southern hemisphere for the Coriolis force. Other questions like these, talking about pressure gradient and Coriolis and winds and geostrophic balance, those should all be related to what goes on in the northern hemisphere. All right, so I hope that was helpful. I'm going to have this, I'm going to take this recording, I'm going to post it up. And I might do the Pear Deck as well, but I'm going to do that separately. All right, well, you guys have a good day, and I will see you soon.